Well, good morning, good afternoon, I guess, for many of you. Thanks for giving us the opportunity to speak to you today. I have to say this is a topic that Britton and I have an enormous amount of passion for, and I think the only regret is that we only have a 30-minute time slot here, so you're going to get a very condensed and probably fairly quick run through, I'm afraid. So let me just dive straight in with some introductions. As Prab introduced, I'm Elwyn McLachlan. I'm the Vice President for Product Development for the Civil Construction Division at Trimble. I'm sure many of you are familiar with Trimble or use Trimble technologies. I saw a number of our products mentioned in the previous speaker's presentation as well. But in our division at Trimble, we work on machine control, construction surveying, site management solutions. I'm going to talk a little bit about some of those today, but actually more generally about the exciting technology innovation that we see going on in the industry. Just a little more about me. I'm 25 plus years with Trimble, predominantly in product development. If you're wondering what this funny accent is, I'm originally from New Zealand. Started my career with Trimble in New Zealand, where we do a lot of product development and testing. My father was a contractor, so I grew up in this industry. I grew up helping him do takeoff with his scale rule on his paper plans at the kitchen table in the evening. So I know very well a lot about how far this industry has come, but I'm also really excited about what's still coming down the track. And again, this is what we're going to talk more about in the next 30 minutes. So now I'll turn the floor to Britton.
Yeah, Britton Lawson, Director of Construction Technology for Veit and Company out of Minneapolis, Minnesota. We are a specialty contractor based in the Midwest. We provide scopes in earthwork, utilities, deep retention systems, demolition. We've got a waste division where we're managing 2 construction and debris landfills. I've been with the company 10 years, and I've been in the industry for 20 plus, and involved in technology for probably 17 of those years. So my background started with boots on the ground in the field, running equipment before technology on the grade control side of things, and just transitioning through field management positions and eventually to where I sit now, and overseeing our survey group, and then working on field to office solutions in terms of how we're managing in-site solutions for our projects. A lot on the fleet side, and work with our fleet teams very closely with telematics and managing our fleet side of things, and then the business intelligence of trying to get this data that we're getting from all of these systems that we can make actionable decisions on. So I'm excited for where this session's going to go. I'm excited for where the technology is headed as well. So,
thanks, Britton. I think and Britton probably undersells himself. He's one of the best technologists that we work with. We partner with it here at Trimble. He uses his downtime in the winter to try out lots of new and interesting things and give us a lot of feedback. So I thought it'd be really good to hear Britton's perspective as we walk through here on how he and Veit are looking at some of the technology that's coming down the track and where they see the potential. The reality check, if you will, on what really works for construction. So, as I said before, we only have 30 minutes, so we talked a little bit, Britton and I, about how to highlight some of the more exciting things coming down. I think it would be a huge miss if we didn't spend some time here talking about artificial intelligence, and we're going to focus in particular on the pairing of artificial intelligence and reality capture. Brian, in his last presentation, talked a bit about how they're using drones to do bridge surveys, and we're going to talk here about how you when you get these massive amounts of data that reality capture allows, how do you then interpret that data efficiently so that you're not overwhelmed by data? Talk a bit about autonomous equipment operation, which is an area that we've got some investments in here in Trimble, and talk about what we're learning out of that, and how these things can help optimize site performance in general. And then Britton's going to talk specifically about how, as a contractor, you can get involved in new technology capabilities that are coming down the track and not get overwhelmed by them, right? I think for many contractors, it's a case of there are so many things happening. What do I pay attention to? What do I try? How do I make sure it's successful? Contractors aren't in the business of managing technology. They're in the business of construction, and so how do you make sure that this new technology is an enabler and a tool and not a burden that weighs heavy on your shoulders? So that's the topics. Let's get into them. So AI and reality capture, where are the advantages here? The real advantages are in automating repetitive processes, or as Brian referred to, getting access to data that was really hard to access previously. So things like those bridge surveys, looking at pavement surveys and so on, where manual processes are just so slow and laborious that many DOTs and cities and so on just don't have the bandwidth to do them. But reality capture and the reality capture tools really enable so much more in that regard. They enable you to identify errors and improve quality. So again, the bridge surveys are a great example of that. Improve compliance and of course, improve safety. One of the things in this theme about technology today, and as you can see, I'm really passionate about this space. It's what I've dedicated my career to, is the opportunity we have to improve safety, to improve productivity, to reduce waste and rework, to use our limited budgets and dollars effectively on the right places to really target them, to address the worker shortage. A lot of what we're going to talk about today is about doing more with less, or automating repeated and manual tasks so that we can free up our limited resources to do the higher value work. And of course, to touch on sustainability, how can we reduce material usage or place materials more efficiently to reduce waste and rework that all contributes to sustainability. So reality capture, when I say reality capture, what am I talking about? The, again, exciting thing in the industry today is how many different tools are available. I grew up in the era of GNSS, so really putting GNSS or GPS to use in construction for the first time. But in the last 10 years, it feels like this space has really exploded. We're seeing both the availability and the cost of tools come down, but also the ease of use and the application. So instead of kind of generic LiDAR, what is LiDAR that's really specific to the use cases in construction? How does scan data get applied to the use cases in construction? Drones, phones, planes, trains, so many different sources of data collection, and a little photograph here showing some of the tools that are available and some of the tools I know that Veit is putting to use on projects, and I'm sure many of you on the call here today are as well. So what's the downside? The downside is so much data that it can be overwhelming. And this is where, for me, the pairing of AI and reality capture just makes so much sense. These are statistics that one of my colleagues presented earlier in the week and shared over with me. 2.18 million points per second that a scanning system, that a LiDAR system can collect. I mean, that blows your mind. 8 billion points per hour, 190 gigabytes of data in an hour. How does a contractor, how does a DOT deal with this kind of volume data and make it useful and serve just the right data to the right user at the right time to make the decision that needs to be made? So that's where AI comes into effect. So here at Trimble, we are experimenting with and having good success with and releasing solutions that are about feature extraction and object extraction from these massive data sets that are available to you. So with AI and machine learning algorithms, we can train those algorithms to detect features and objects of interest, both from a data cleaning and data simplification standpoint. How do you eliminate unnecessary data just to surface the data that you're interested in for the task you're trying to achieve? But how do you also automatically classify that data to make it useful? What you're seeing on the screen there is stockpile surveys. And so I want to turn the floor to Britton to talk a bit about how they use stockpile surveys at Veit. Oh, Britton, you're on mute, my friend.
Thank you for that. So when you're talking about big data and trying to get it, even before we get to the feature extraction, it's very, very labor intensive to be able to process that data. So once the raw data comes in, we can use tools that are classifying the points and eliminating a lot of the time. When we first got into drones probably 7 years ago, there was a lot of labor intensive office time that we were going in and scrubbing out all of your trees, all of your grass, all of your vehicles on site that we could actually get a true ground survey. So now there's tools that are reclassifying some of that. So it's just vegetation or it's miscellaneous objects or buildings. So now we can start to eliminate some of those things from the model in a retroactive standpoint, but still saving a ton of time. And it's an automated process that we've we've been able to leverage quite a bit. But recently we started using a drone platform that is actually, as it goes in to be processed, now what it's doing is it's through the processing platform, it's actually running all those algorithms, and it's actually spitting out a more true ground model. So instead of having to spit it out and reclassify all those points, it's giving us that model that's basically a workable data set. Now that we've got it to a workable data set that we can use, obviously we went out and captured that data from a standpoint that we needed to take action on something, whether it's a progress survey or whether it's the stockpiles in the image. Traditionally, we would go around and we would trace every one of those piles manually, and then we'd run a calculation on that one stockpile, and we'd get our quantity and we'd share it. But in the example, now there's tools that are basically saying, here's the breakpoints, and we're identifying these are the stockpiles I see on the job site, and it's creating automatically all at once those stockpiles, which saves a ton of time. But you go further than stockpiles. I mean, you can take a scan data set and classify trees, the size of trees, the inch in diameter, what the trees are. We can extract curb lines out of for an as-built out of a photogrammetry data set to be able to create the as-built for the end of the project. So these are all scenarios that would have taken a ton of time within the office that we're able to leverage some of these tools that'll really have really streamlined our processes already. So
that's great stuff. Thank you, Britton. Moving on, I wanted to share with you some of the more experimental work that we're doing with AI. So you can see how you can move from simple feature identification, object identification, and object extraction kind of in a post-process way, right? As Britton said, when we need to get those stockpile volumes so that we understand how much material has been used in the last week or the last month. A fairly, what we would now call simple, we wouldn't have called that simple 5 years ago, let me just say that. But on the screen here, what you're seeing is a little video clip of a live, what we'd call edge processing AI example. In this example, the algorithm, the services have been trained to identify both the bucket of the excavator as an object and the dump truck as an object, so that it can track the cycle time of that load and cycle operation, right? The time it takes to load that truck, the time till the new truck arriving, and so on. Again, this is an experimental program that we have at Trimble, but I'm really excited about the potential of how we can monitor and track more real-time activity on the job site. Again, my focus is construction. I think about that, and I think we're going to hear some more for some speakers this afternoon about how we can apply that in highway operations and other types of infrastructure problem sets. But again, this one I thought was particularly exciting, and I'm sure many of you who work in construction can see the potential for automating this kind of monitoring and tracking task from a productivity or production standpoint. And also, of course, there are applications in safety as well, where you can identify those objects in real time. And we'll talk a little more about that.
Ellen, I'll jump in here a little bit too, and I think a lot of the features that we have currently, there's a lot of human interaction, so there's a lot of human input from an operator standpoint. And technology like this will start to really clean up that data in terms of identifying what actually went into a truck. An excavator operator is tasked with loading vehicles or loading material into the trucks, and they're quantified by a loads per hour or quantity or yards per hour for what we bid the project at. So they're not going in and identifying all the material that they moved that actually went into a vehicle. So we're able to really hone down on actually what left the site or what went into a vehicle. So I think I'm excited for something like this to come to one of our projects.
Very cool. All right, so the next one I just want to touch very briefly on. In fact, in some ways, I would call this the most boring of the AI examples that we're going to talk about today. But nonetheless, when we talk about, again, the worker shortage, how can we help automate labor-intensive tasks and error-prone tasks? At Trimble, we tend to refer to this as auto magic invoicing, with an emphasis on the magic. This is where we have trained these algorithms to read data off of the paper forms and the PDFs and the emails that you get your invoices in, and extract that information automatically. So save that manual re-entry that office worker is doing for your organization. Not only, of course, is it fast, it's lightning fast, but it's extremely accurate as well, right? So when you've got someone manually keying in, you get transcription errors, you get missed data, you get spelling mistakes, which make it hard to classify and search for the information afterwards. Using automagic invoicing, you can automate that entire task.
And we're using some of this OCR technology too when we're uploading plans to our plan collaborations suite. It's also, we're using it to create our submittal logs. So instead of combing through a spec section, the technology is actually combing through the entire spec book and pulling every single submittal out. So instead of trying to figure out what we have to, we can go through every requirement in the submittal book and say everything that we don't have to, which is probably a much shorter list than the amount of pages on a spec section. We're also using some of these automated tasks and when we're creating the 3D models for machine control. A lot of macros that are available to us in Trimble Business Center are streamlining our ability to create models at faster, more accurately without having to click along that, which gets us our field data out to the field users faster. And then obviously the drone photogrammetry that we're constantly leveraging in the processing platforms that we've talked about, I think are all great example of automating some of these tasks that we're using every day right now.
Fantastic. Thanks, Britton. All right, so we're going to turn to a different topic now from a technology standpoint and talk a little bit about autonomous equipment operation. I think I'm probably preaching to the choir, but when I go through why do we think autonomy makes great sense in construction, I'll just pause and note that many of you will be thinking, hey, we've had autonomous equipment in mining for a long time, and why is it very different to have autonomous equipment in construction? The difference is that a mine is a controlled site where you can really limit who comes onto the site and have autonomous machines operating where no other humans are operating, monitor that. It's a repeated site. So the investment in setting up that site and having it running continuously has enormous dividends. Come to construction where you have projects that are changing constantly. By definition, the very active construction, the ground is changing constantly, subcontractors are coming on, materials delivery is coming on. A construction site is a much more complex beast. But we know, we certainly know that there's a lot of interest in the promise of autonomy in construction. First and foremost, more than anything, about the worker shortage and how can we get machines, one worker managing multiple machines, for example, or machines genuinely completing a task by themselves without a worker in them. Those are the things that we're really investing in at Trimble, where we've got a number of experiments and more than experiments, product development underway. Obviously, optimizing task performance also has advantages in reducing fuel usage and CO2 emissions. We did a study last year looking at our autonomous compactor, our guided compactor, and looking just at the savings in the pass-to-pass comparison. So where you're minimizing the overlaps on the passes and compacting just the material, exactly what needs to be compacted. And we demonstrated an over 30% fuel usage, a 30% reduction in fuel usage and accordingly CO2 emissions by really honing in on that pass-to-pass accuracy. And the third thing, of course, more than anything, is safety. Where we see contractors today most interested in getting started with autonomy are in operations which have a greater safety risk, things like fly ash compaction, where the operator is putting their life at risk, and that's something obviously we all want to get away from. So what are we doing here at Trimble in autonomy? A lot of the work that's going on is around sensor fusion. This is very similar to the automotive industry, the cluster of sensors that needs to come together to serve an autonomous vehicle in terms of object detection, LiDAR, radar, comms, GNSS for guidance is a complex set of things. And with the bar for safety so high, that's a big project and a big investment. The other thing that we have a lot of work going on in is mission and task planning. The thing I think that we very much focus on when we talk about autonomy is the operation of the equipment itself. But in fact, the task or the mission that the equipment is on is also a really important part of how we plan and give that guidance to the equipment. in today's world, when you need to tell an excavator operator or a compactor operator what they have to do, the foreman will step up and they'll have a chat with them. They'll give them some direction. Maybe they have a display in the cab that has some guidance on it, but there's always that kind of human interaction and that explanation or a chance to answer questions. An autonomous machine can't do that. So when you have to give that autonomous machine a task to do, you have to prepare that whole package, including kind of what if scenarios. What if I hit an obstacle? What if the material is not coming out as I expected it? So the machine can make those decisions like a person can. Obviously, object identification and error detection, we talk a bit about that. And then we also have to think about not just an individual machine, but how a group of machines works together in an autonomous way. The photograph I actually have on the screen here, I know doesn't look particularly exciting, but it actually is really exciting. It was our first fully autonomous operation of our compactor on a live project site in Canada. This is the Site C Dam project in northern Canada, a project that the contractor was particularly interested in trialing autonomous vehicles because there is a safety concern. The compaction is happening on a high wall of a dam. Obviously, you need to compact right up to the edge of that high wall, and there is risk for the operator. So they're particularly interested in how could they get an operator out of the equipment. It's also a project where staffing is challenging because it is so remote. You having to fly in staff, workers to operate these machines. So how can we reduce the dependence on workers? I wish I could show you a video here. I wasn't sure how good the connectivity be, but seeing this compactor following the dozer as the dozer is spreading the material and the compactor's coming in behind it to compact that material, again, looks like a small thing, but it's a really exciting step forward in the industry. So excited to see that really happening now, and we have this in active testing around the world with some customers. When we talk about autonomy at Trimble, I want to make it really clear that this is not a big bang, right? This is not something that, today we don't have autonomy and tomorrow we will. We talk about it as a journey and steps along that journey. In that way, it's very much like what you see happening with the automotive industry and the ADAS, the Advanced Driver Assistance Program, little incremental features being added to the equipment that make it more autonomous, right? That take particular tasks out of the hands of the operator that the machine can do for them, that will eventually all kind of stack up to result in a fully autonomous machine. So Britton, I wanted to let you talk about that.
Yeah, so Elwyn makes a great point. Autonomy is going to be a slow adoption as the technology evolves, as clients accept it on the project sites. We work for clients that are, they don't trust it, they don't understand it. So we need to help them be more trustful of the technology, and then what tasks are the technologies are capable of. So there's going to be steps along this journey that are going to help us streamline and introduce and adopt autonomy on a project. So for instance, operator assistance, we've been able to automatically control a blade on a dozer and a grader for many, many years. But as the sensors get added to the machine, it enables more control. So it helps with the vertical control, but it also enables us new features. For instance, steer control was just released. Is it a big needle mover to have your dozer steered for you? You could argue it on an ag side, or for instance, the mining side in those very, very controlled environments. But on a dozer following a curb line, is it going to be a big needle mover compared to vertical grade control? Probably not as much. But it's necessary for that stepping stone for autonomy. So now they're getting feedback as these assist features are being developed. They're getting feedback from the operators, people that are actually in the seat of, I want it to work like this, not like this. So as that journey comes along and those stepping stones are achieved, and it's more created off of human interaction, you're going to be far better off when you actually remove the operator from the seat. Safety features is another big one. Obviously, Elwyn talked about it in the previous slide. It's probably the most important part of the conversation. It's why we're not being led onto job sites with an autonomous vehicle. At the end of the day, whether we have an operator in the seat or whether we don't, we want our people to go home safe, period. And that's one of our biggest, that is the biggest goal at the end of the day. No amount of productivity will eliminate that goal. So we need to have systems in place, and we need to be able to trust those systems. So similar to the operator assistance side of things, there's starting to be, object detection and people avoidance and object avoidance on machines currently. As they talk about dynamic and dynamic avoidance zones that just got released or that they're working on, is it's the next step from 2D. So right now, a 2D avoidance zone, you have to reposition. Every time you reposition a machine, you have to recreate that avoidance zone, stopping the machine from swinging or entering into that avoidance zone. Now with a 3D avoidance zone, it can be programmed right into the model. For example, on the side of a highway, you're doing construction along the side of the highway and you've got live traffic right next to you. You don't want that excavator swinging in with the counterweight or the bucket into live traffic. So that dynamic avoidance zone is now going to stop that from happening with an operator in the seat. But to vet that out and have that redundant backup for somebody if the technology were to fail, they're able to control that with an operator. And again, to that stepping stone of when they do take the operator completely out of the seat. So and the next thing is just going to be, what are the specific and the relatable tasks or repeated tasks? Automation and autonomy work well in that controlled environment, in ag for auto steer, for mining because you're running that same road. There's not people coming in. It's very predictable. It works really well and excels in a predictable environment. But and it takes those tasks that can be repeated over and over and over, and it's easy to be able to program that. It's easy to deploy that mission. But there's far more variables on the civil construction side. So there's buried utility lines that may or may not be marked, with a GPS accuracy. There's other trades that we're working around in a commercial environment, right? So there's a lot of things that we have to take into control, but it's very, very easy to identify tasks that autonomy cannot do. It's very easy to say, oh, it won't work because of X, Y, or Z. But at the end of the day, autonomy is still a toolbox, right? Or it's a tool in the toolbox. So grade control, when it first came out, was not applicable on all of our job sites. Now, I would argue it's 90% applicable on most of our job sites. Autonomy is the same thing. It's going to be a slow roll, right? So identifying things that are very redundant. And as those tasks grow, we'll be able to program and calibrate the equipment, and it'll start to get more experience, and then that the adoption will grow and grow and grow. So, and then the more tasks will become applicable because it's got experience at other things, and it creates opportunity for the development. You can go to the next slide.
All right, Elwyn. Yeah, Britt, we've got no minutes left, so I'll let you wrap up with talking about how a contractor like Veit stays on top of all of this rapidly evolving technology and puts it to good use.
Yeah, I'll wrap up real quick here. So, why is it important? If you're not looking at your tech stack every 3 years, you're probably falling behind. So, technology and software is evolving. There's features coming out constantly every single year. So. It's very, very important that you continue to look at that. I'm not saying you need to change every year. We're standing up a new ERP next Monday, and I don't wish that upon my worst enemy, but we're going to do it, and we're going to come out on top at the end, right? So the autonomy race is real with workforce challenges and the drive to do more with less. It's going to evolve quickly, and it's going to grow quickly. Follow on social media, talk to peers, go to these construction expos. That's going to get you through. We participate in beta testing on a regular basis with Trimble, CAT, and it benefits us. It's a mutual relationship. It helps us drive the progress and what's actually going to work and not going to work, and then also be able to have our thumbprint and see into the future a little bit. So if there's any opportunity to do that, I encourage you to do that as well, because we're better together. And I would say adopting and sourcing, have a goal. What do you want to solve? There's a lot of shiny objects that'll solve big problems, but what do you want? What's your end goal to be able to get through? Identify that and source a product. The one biggest thing I will say when I talk about technology is have a champion, have somebody that oversees it and champions it. You get out what you put into it. If you're not going to put anything into it, you will not get anything out of it. You'll be disappointed. So have somebody that owns that software, that grade control product, the AI, whatever it may be, have somebody that owns it and runs to the finish line with it.